Hey guys, welcome to another LeetCode tutorial. In this video, we'll be looking at how to remove duplicates from a sorted array. This problem is of easy difficulty. So let's try to understand the problem first. Um, so when we are looking at the problem statement, it says that we are given an integer of array nums, which is in a sorted and non-decreasing order, which is also known as ascending order. So we need to remove the duplicates in place, which means we shouldn't be creating extra space, like creating a new array and then basically pushing the elements, unique elements from the current array into a new array. That is not allowed. So it has to be an in place change, uh, and the relative order of the elements should be kept the same. So the order needs to be maintained, and all we have to return is the number of unique elements after we have removed the duplicates. Another thing to note here is once we are done with building the unique set of elements in the nums array, which is like deduplicating all the duplicates and like leaving the unique elements, that is set to be k. Those distinct values are set to be of length k, and that is what needs to be returned. And whatever is there beyond those unique set of numbers, we don't have to care about it, and we can directly submit our solution without caring about what are the numbers after those k elements, right? So the answer will be accepted as long as the first k elements are unique. Okay, let's take an example to understand it in a better way. So I'm going to copy this here, and we can discuss our approach. Okay, in this case, we are given a nums array of 1, 1, 2. Our solution will be we need to return 1, 2, right? And then we don't care. So 2 comes into one's place, and then the 2 can remain like that. It doesn't matter. The answer that we need to return is just 1 and 2, which is of length 2, right? So that will be our answer. And then if we take another example, bigger example, in this case, we have multiple zeros, three ones, two twos, three twos, and one four, right? So the answer will be 0, 1, 2, 3, and 4. And whatever numbers that are left after these unique numbers uh, are not considered as part of the solution. So all we need to do is 1, 2, 3, 4, 5. 5 will be our solution. So we need to return 5. Okay. So that's how we need to be doing. So now now that we understand what uh, what should be the outcome of these examples, let's try to discuss the solution. So I'm going to pick the biggest array within these two examples. Okay, now the point of this question is it's a non-decreasing order numbers within an array. So that means the first number is always correctly ordered, right? Because it starts from the lowest to the highest. So we can ignore the first element and maintain a pointer here and another element called I, which is used for our loop. Okay, I'm going to explain what these are. So I is just a variable for us to iterate through each and every element through the array. And P is the one, you can think of it as a pointer or a pivot, which is basically uh, to determine where the last unique element was found, so that we can move to the next one and then keep on placing unique elements in the place of P. So that's like a pointer for uh, for for us to manipulate the array with a unique number. Okay, so if we take this example, what will happen is we need to check first that if I and the value before I are equal or not. If they are equal, then that means uh, we have a duplicate, right? So what we need to do is when we have a duplicate, we need to uh, we need to move our I pointer to the next one, and we know that this P should be still pointing here because this is a duplicate and this value needs to be replaced. Now we need to check if I value is equal to I minus 1 value, which is 0. So 1 and 0 are not equal. So what we need to do is we need to find where P is and copy the value of nums of I into P, and then move our P pointer one step ahead. And our for loop will also increment I after the end of the loop. Now we need to check if I and I minus 1 are equal or not. They are equal. So you just keep on moving. Again, you do a comparison of I, nums of I and nums of I minus 1, which is also equal. So you keep moving your I pointer. Now you check whether nums of I is equal to nums of I minus 1 or not. They're not equal. So we found another unique number. So what will happen now is we are going to copy that number and replace that in the place of our pointer P, and then move our pointer. Okay. Now our I will also get incremented at the end of the loop. Now for I, if nums of I is equal to nums of I minus 1, it's still equal. So you keep on moving whenever you find equal numbers. Now you see nums of I is not equal to nums of I minus 1 because 3 and 2 are not equal. That means you copy nums of I and replace. You need to find where P is pointing to currently and replace that value with the nums of I value. And then you move your P pointer to the next value. Now, I will also get incremented at the end of the loop. Now we will see if nums of I is equal to nums of I minus 1. It's equal. So we will go further one step. Now, if nums of I, which is 4, is equal to nums of I minus 1, this is not true. That means we'll copy nums of I. We found a unique element and we are going to replace it at P. And then we are going to increment P and also increment I. We will hit the end of the loop. And then what will be remaining? I mean, will be at P, right? So it's going to be 0, 1, 2, 3, 4, 5. So that means our value or our array has 5 unique elements. So we'll be returning P. Now let's write the solution here. So I'm going to have let. So first let's check the base conditions. So nums of length will always be 1, right? So that's the constraint. So we don't need to check for any equality. Sorry, we don't need to check for nums dot length equal to 0 condition. So we can just go ahead and work on. Let's do this. If nums dot, since we are starting from pointer 1, right? What if nums dot length is just 1? If nums dot length is equal to 1, then you just return 1, right? That's the only unique non-duplicate element present in that particular array. Otherwise, we are just going to create a pointer P which is starting at index 1, and also I which is also starting at index 1, I less than nums dot length, I plus plus. As I've already mentioned, why we are starting at 1, because the first element of a sorted array is always in the right place because it starts from the lowest to the highest. So the lowest number is always at the front of the array. Okay. Now, what the logic here is, we are going to check if nums of I is not equal to nums of I minus 1. If this is the case, then we know that we have found a unique element at nums of I. Let me put it this way: nums of I minus 1 is not equal to nums of I, so that the I is on the right hand side of the equality check, and then we know that we need to update nums of P equal to nums of I. First, we copy nums of I into nums of P, and then you're going to increment P plus plus, and then after we come out of this if condition, I also gets incremented, and then finally, wherever P ends, that is going to be our total number of distinct elements. So we are going to return P. So yeah, let's try and run this. So it has worked for 1, 1, 2 and the other case as well. Let me add one more case to test our base condition here. So if there's 1 and if I run 1, okay, so that is going to work for us. If it is 2, it's going, this conditions are going to take care. So if it's just nums of length 1, we are just going to return 1. So let me go ahead and submit this. All right, now it looks like our solution has been accepted, and that's how we'll be solving removal of duplicate elements from a sorted array. If you have any questions regarding this, please feel free to ask those questions in the comment section. I'll be happy to answer any questions that you have. And yeah, if you've learned something from this video and liked it, please consider subscribing to my channel and also like this video. Thanks again for watching. I'll see you in the next tutorials.